Today I'm going to discuss a clever way of getting power and data out to APs that I recently installed for outdoor Wi-Fi service on the green at Dartmouth College. No, not that green, this green. The large open grass area in the center of campus. It's a popular hangout spot for students, staff, faculty, local residents. It's frequently used for events such as commencement every June, the homecoming bonfire in the fall, and even a temporary ice skating rink that's 120 by 70 feet wide. Not to mention outdoor classes, study groups, frisbee games. If you know anything about Dartmouth, it's that Dartmouth loves the outdoors. Aside from the green, so much of the appeal of the campus is its location. It's just a short walk from nature. And that's why we were so excited to finally be providing outdoor Wi-Fi in this much beloved space. Well, part excited, but also a good part puzzled. Because as we all know, there's a lot of wires involved in wireless. Running them outdoors is a lot harder than running them indoors. The Dartmouth Green, pictured here on Google Maps, is a 7.5-acre plot of land surrounded on all four sides by public roads. No existing telecom infrastructure. But the students had spoken. Collectively, they all voted and decided to cut the cord. They ditched the TV service we were offering to them for free and said, please use that money to install outdoor Wi-Fi. So this project, after years and years of trying, was finally happening. The direction that I was given was to provide basic Wi-Fi service for 400 users maximum. So things like email, chat, light web browsing. Needless to say, that was an understatement. The installation, which we completed in October of last year, has been seeing well over 400 simultaneous connections per day. During homecoming, that photo with the giant bonfire, we saw over 1,600 connections. Where to put the APs and how many to install was actually the easy part. I was told that. They could go on the existing lampposts. Even though placement was non-negotiable, the predictive RF coverage actually wasn't bad. The actual RF coverage ended up being very similar to what was predicted. So let's dig into the topic of this presentation. How do you get power and data out to an access point when it's too far from your network equipment? How far? Well, Hamina tells me that this one access point, even with a fairly straight shot pathway, is over 900 feet from my nearest existing telecom room. That's way too far for normal copper Ethernet, right? And this wasn't even the farthest AP I had to get power and data to. So how long can a twisted pair Ethernet cable be? Well, I was expecting a lot more people to say it depends, because I'm referring to Cat 6A cable, 23 gauge wire, 1000 base T and 30 watts PoE. If you change any of those values, the length of your cable can change. 1000 base T does run 100 meters, 328 feet. At 20 degrees Celsius. Anybody know that part? As we all know, the IEEE works in a very theoretical world, often very far from reality. Fortunately, there are groups like BICSI, the Building Industry Consulting Service International, who are a little bit more down to earth. They publish a fantastic document called the TDMM, the Telecommunication Distribution Methods Manual. If anyone here is involved in designing or installing cable plant, I highly recommend you read it. It's full of all sorts of best practices, great tips, things you should be doing. They take that 100-meter recommendation and shorten it down to 90 meters. Anyone know why? Patch cables. Some people have read this. So they allow for a 5-meter allowance on either end for patch cables because those do have length too. A seasoned Layer 1 veteran will probably take that and shorten it even a bit further to include some more slack on each end for maintenance and future repair work. And if you have ever really designed outdoor cable plant, you're going to shorten that more because no pathway is ever straight. There's always vertical changes. Your tape measure might have been a little short that day. You forgot to hit add on your laser when turning a corner. So copper's not going to cut it. How long can a fiber optic cable be? Let's try the next best thing. Alcatel-Lucent currently holds the record, at least according to Wikipedia, 100 gigs a second over 7,000 kilometers. That's way more than I needed. In normal enterprise, using OS2 single mode fiber 1 gigabit per second. 10 kilometers is where you're looking for fiber. And if you're going more than 10 kilometers, chances are you're not putting an access point on the other end of that cable. Fiber optics are great for data, but what about power? Quick disclaimer, I am not a licensed electrical engineer, although I do play one on TV. I'm going to be broad stroking a lot of the details here. My example is not a cookie cutter recipe. It's not one size fits all. I'm also focusing on US requirements. So if you're going to go and say, yeah, Bryan said to do this and this is how to do it, make sure you're following the rules that apply to your area. So, that said, in order to determine how long power cables can go, you need to know what type of cable it is. Most of us here know the difference between Cat5 and Cat6A, and there's just as much, if not more, complexity in power cabling. Where do you find out the properties of electrical wire? You need to know the size, whether or not it's stranded or solid. Is it copper or aluminum? You should be using copper, in case that's a question. And is it insulated or not? You take all that data about the type of wire you're considering, and you can look it up in the National Electric Code Conductor Properties Table, which is as complicated as the MCS tables. This table only tells you the resistance of the wire at a single given physical temperature. It does not tell you how long you can run it. You do some more math, and that gives you yet another value, the voltage drop. It's like free space path loss. The farther away you are from the source of energy, the lower the amount of energy at the receiver. It's the same with radio as it is with voltage. And you need to know how much voltage loss is acceptable in your application. Fortunately, calculators exist. Vendors who work in this space often have customized calculators or spreadsheets, and conveniently they'll make recommendations about which of their products are best suited for your application. We're going to look at one in a moment. Voltage drop does exist with power over Ethernet. This is why the wattage at your power sourcing equipment is often higher than the wattage at the powered device. So for 8023AF, 15.4 watts at your switch translates into roughly 13 watts at your powered device. For AT power, 30 watts results in 25.5 watts at the powered device. So how much voltage drop is acceptable for PoE power? It depends on which PoE standard your device uses. If you look at the chart here, if you're using AF, AT, or BT, the acceptable voltage range is actually slightly different. I'm not even going to talk about non-standard or passive PoE power. Those things just shouldn't exist. Okay, so what? Look at the National Electric Code, do some math, just throw a PoE injector at the far end of this cable and light up your access point, right? Well, does anybody know what size copper wire is needed to run 120 volts for a 15 amp circuit at 300 feet away? 4-gauge wire. That's about the diameter of a Sharpie. For comparison, your home or office typically has 14 or 12-gauge wire. Oh, and you're going to need 3 of these, hot, neutral, and ground. It's not just the one wire. At current market prices, 4-gauge wire, a bundle of 3 is $3.50 per foot, whereas Cat6A is 87 cents a foot. So running mains voltage power out to a remote access point, not very cost effective. You'll also need to ensure that this wire is rated for outdoor use. Be careful of the bend radius. Trust me, that 4-gauge wire does not like to bend. And if this all seems like it's a lot, it's because it is. If you're planning on doing outdoor cable plant design, I recommend you hire a registered communications distribution designer. It's like hiring somebody who's CWNP certified to help with Wi-Fi. There are people who specialize in this, and they know what they're doing. But what if we could run power as far as we could run data? This is where this concept of hybrid powered fiber comes in. And I'm not talking about some magical thing where laser beams are powering your access points, although scientists are working on that, I hear. This is a real product that I found from CommScope, and their own marketing drawing clearly shows the concept. You have a head end, which is in a rack that provides power and connects to a network switch of your choosing. Then the powered fiber cable runs out to these PoE extenders, which provide a normal copper Power over Ethernet handoff to your access point, camera, whatever it is you're running. The powered fiber cable isn't anything magical. It's just a fancy cable assembly that combines both copper and fiber into one jacket. But it is both designed and rated for this outdoor application. CommScope, the engineers there, they figure out everything, the wire size, the length, the voltage drop, the environmental considerations, and their product comes in a few different variations, but they're all pretty much similar. At the far end, how do you then convert that? Well, they make a matching PoE extender, which is really just a combination media converter and PoE injector. It comes in a few flavors, including one that provides two 1 gig 30-watt ports. While these are IP68 water rated, and they are also designed to be installed on the side of a utility pole in direct sunlight, they do have some caveats. One, they're not remotely monitorable. They just behave like a dumb media converter. And two, which was a big problem for my installation, they're not rated for direct burial. Let's talk about the head end, the source of the power and data. At the top, I have a Juniper EX4400 switch with 32 SFP cages. So you need to have a switch that's providing a lot of fiber optic output. The next 2U below that are the power supply. And it provides more than 48 volts DC to account for voltage drop at the far end. And if you look closely, you can see this one's providing 57 volts. There's some assembly required too. You'll have to have a qualified person make up the power wiring, which includes some beefy 6-gauge DC power cables, and of course all the output power. Grounding with this is critical. As it's a DC system, there's no inherent ground, so you'll need to have someone who knows where and how to make that proper connection. For the power supply itself, it is network accessible, although there is no command line or API, and the GUI looks like it came straight out of the Web 1.0 era. Still, it's been a very solid and reliable product. At the far end, I was able to mount the MIST AP63s on light poles. But again, strapping a PoE extender to the side of the pole as well wasn't going to be approved for aesthetic reasons. There was also no space inside the light pole to put the extender, so we installed Quasite handholds at the base of each pole. Because this extender is explicitly not rated by CommScope for direct burial or for ground contact, it had to be installed within yet another enclosure that did have those appropriate ratings. Inside the extender is some really well-designed cable tray and cable management and fiber splice trays. The copper wires carrying the electrical power simply connect to a terminal block. You install SFP modules into the cages, one for each port. Terminate, connect the fiber, connect the Ethernet cables, and close up the box. There's a couple of LEDs and some jumpers to monitor that it's receiving power and to set speed negotiation, but that's about it. Since this is an outdoor environment, some other things to think about included temperature-rated SFP modules. Those exist. They can handle a wide variety of temperature ranges. There's no heating or cooling in these handholds like you have indoors. The equipment's getting exposed to the weather, not just the rain or snow. Drainage of the water within the handhold is important. Although the extenders in the box I selected were IP68 rated, IP68 doesn't actually mean it can sit in a puddle of water for a long period of time. Accessibility for installation and maintenance is also key, but so is physical security. So we wanted to make sure that the lids for these handholds were either sufficiently wrenched down or you can get tamper-proof bolts. Another point on the lids, they have to be rated for traffic, be it foot traffic, lawnmowers, or a box truck with a literal ton of wood going to build a bonfire. The handholds, in one sense, are a lot bigger than you think, but they're also a lot smaller on the interior. So I spent a lot of time drawing this up in 3D AutoCAD to make sure that everything would fit before we ordered parts, make sure the cable bend radiuses were acceptable, and then also have good documentation of how it should look when it's done. Cable from the extender to the access point. I think I heard somebody complaining about it last night. You have to make sure you have the cable that doesn't have boots on it. Otherwise, it won't fit inside the cable gland. We used CommScope's shielded outdoor Cat6a cable that goes from the access point into the lamp post, down into the extender. As for mounting the access point itself, I don't like to use hose clamps because it just feels amateur. There's a product out there called Permaband, and that's what's used for traffic lights and cell towers. It has ratings for weight and weather resistance. Since most outdoor APs are designed to be mounted with hose clamps, this is actually a very drop-in replacement with a much more professional feel. Additionally, using the wraparound mount, even if it is a hose clamp, means I'm not drilling into the side of this lamppost, I'm not turning it into Swiss cheese, and it allows for future replacement or upgrade of the access point and bracket without causing additional damage. As for the hole to get the Cat6 cable into the lamppost, duct seal is your new best friend. Imagine duct tape and Play-Doh had a baby. You just kind of smush this around the hole in the cable, and it creates a totally weatherproof seal. If anybody's ever used coax seal for antennas, it's a very similar concept. So, how long can I run this powered fiber cable? My farthest AP was 1,200 feet away. The pathway wasn't perfectly straight, so we trenched and built a whole ring of conduit around to hit every lamppost. And working with the engineers at CommScope and their calculator, as you see here, they determined that I could run this cable for over a mile, over 6,000 feet, for 1 gig 30-watt PoE power. If I didn't need 30 watts, say I only needed 15 watts, I could go 10,000 feet. Or if I need 60 watts of PoE for a more fancier access point, or I needed to power 2 from the same extender, still 3,000 feet. That is way farther than you'll be able to get with copper Ethernet. Although the CommScope system is pretty slick, it's been working really well for us. They have a 25-year warranty, which is unheard of for outdoor equipment. I've been thinking, could I have designed this myself? Power supplies do exist. Some of them look just like a network switch where you're just sliding in more power supplies, and it doesn't have any Ethernet, it just has power outputs. Or you could get smaller power supplies, say if you only need to run 1 or 2 of these circuits. Why have a whole rack mount unit designed to power 30 extenders? In addition, maybe you don't want to use this hybrid power fiber. You could do the math and get outdoor rated direct burial copper. Maybe you only need to go 500 feet, and your power requirement is much lower. Instead of the rugged PoE extender, there's a lot of other products out there. Personally, I've become a fan of the Lantronix SIS-PM series. It's not a media converter, although that's what they call it. It's a managed switch. It has a web interface, command line, even a REST API. They also make a matching 56-volt power supply. And because this has no wiring terminal blocks, any low-voltage installer can handle this. But still, there's something especially reassuring knowing that the folks at CommScope have figured everything out, they designed it to work properly, and they're going to warranty it for the foreseeable life of the installation. I spoke a lot about standards earlier on. Basically, if a standard is required by law or referenced in a law, you can get a free copy of it. Same with IEEE 802. The IEEE GET program, you are all eligible for it. You can get a copy of the standard for free. If you work in higher ed, check with your librarian. You can often get all of the IEEE standards for free, not just 802. Sadly, BICSI is not free, but again, BICSI, the TDMM is not required by law, but it's full of great tips and best practices. If you can get your hands on a copy, highly recommended. Otherwise, you can always hire a certified BICSI designer and installer to do your work. And lastly, if you want more information about the CommScope system, here's a link to their webpage. Thank you.